All right, welcome to Acids and Bases Part 2. This is where we're going to be talking about reactions. And we're actually going to be talking about three types. So the first reaction we're going to talk about, because these are all honestly acid plus something, is we're going to talk about acid. Number one, we're going to talk about acids plus metals. Now, acids react with pretty much all metals, except for some very unreactive ones. And when they do, we can always assume that our products are going to be some type of hydrogen gas plus some type of metal salt. Now that's going to be any combination at all of a metal and the back half of the acid. So I think the best way to see this is by actually reacting a metal with an acid. And I'm going to do that on paper, or whatever this program is. So let's take HCl, hydrochloric acid. Now, a quick thing to note is pretty much all our acids always start with H. All acids start with this. And that's a pretty good way to identify our acids. Now, we're going to go ahead and react it with, let's say, magnesium. Magnesium is a very reactive metal. So when we put magnesium and hydrochloric acid together, we get, like I said before, H2 gas plus our metal, magnesium, and the back half of the acid right here, which is our Cl. So we're going to go ahead and put that Cl here. Now, it's Cl2, so we have to be very careful. So if we look at our periodic table, we go back to our thoughts. Magnesium becomes a 2+ ion, chlorine becomes a 1- ion. So we need 2 chlorines to balance the 1 magnesium. That's why we have our 2. And the last thing is we have to balance this equation. We have 2 hydrogens right there, 2 chlorines right here, but we only have 1 right here. So I'm going to put a big 2, and I'm going to go ahead and balance it with that 2. So our reaction of an acid plus a metal is 2 hydrochloric acids plus magnesium creates hydrogen gas and magnesium chloride. The last thing I would just want to note again is that our hydrogen gas is H2. The reason it has that 2 is because hydrogen is diatomic, which means it always shows up in 2s. So that is our basic reaction for an acid plus a metal. All right, our second one, we're going to do an acid plus a carbonate. Now, carbonates are generally going to be our things that have CO3 2-. So anything with this polyatomic ion is a carbonate. So calcium carbonate, sodium bicarbonate, sodium carbonate, baking soda, stuff like that. That's all going to be carbonates. Now, acids, once again, are going to be our H something, H whatever. And so let's go ahead and take a new reaction. Why don't we take, or before we do, let's explain it. An acid plus a carbonate will always produce a couple of the same things. One, we're going to produce, or we'll start with the different ones. We're going to produce water. So we're always going to produce water. We're always going to produce CO2. But lastly, we're going to produce something we did before. We're going to produce a salt. And again, that's going to be some type of ionic compound. And it's still going to have the back half of whatever our acid is. So we can go ahead and take one of my favorite acid plus carbonate reactions. It seems pretty basic, but you know what? I just absolutely love it. We're going to take vinegar, HC2H3O2, plus baking soda, HNaCO3. And we're going to go ahead and produce our H2O plus CO2, and then our salt. The salt's always the hardest part, but really if we go ahead and look at it, we're going to start with our metal. So I'm going to go Na, and we're going to do the back half of the acid, C2H3O2. You might be asking a couple things. Well, first off, where does the water come from? Well, we have 1H, and our oxygen. And these three things will come together to produce H2O. Now, the thing is, we have 3 oxygens. So the remaining C and other 2 oxygens will come together to produce CO2. And then lastly, our Na and our back half of our acid come together to produce our salt. So when you're doing these reactions, everything will just come together, and you can honestly just kind of pick and choose where things go, as long as you still produce your H2O, your CO2, and your salt. All right, so for acid and carbonate, that's about it. So we're gonna go into my last and kind of the general one people think of, which is just what happens when we combine an acid plus a base. So our acid is going to be the H and something, and our base is going to be pretty much anything that produces OH. But what we're going to do is we're going to take a strong acid and a strong base, because I think that's one of the best ways to represent this. So when we take our strong acid, like, oh, you know what? I should tell you what we produce first. When we take our acid plus our base, we're going to produce, once again, a salt. Going to be pretty consistent with that, but we're also going to produce water. Acids and bases neutralize each other to produce water, because something we learned in the previous video is if our base produces OH minus and our acid produces H plus, well, these two things always want to combine to produce H2O. That's just what they do. And what's left over can just go ahead and bond. So let's go ahead and look at HCl plus NaOH. A strong acid, hydrochloric acid, plus a strong base, sodium hydroxide, and we get H2O, because that's going to come from our OH here and our H here. And then the other 2 parts of it combine to create NaCl, the most common salt that most of y'all think of when you think of the salt, just standard table salt. And that's it. That's all we all have to do. A couple things that you want to be wary of is when you're doing these reactions, you always have to balance it. And so when we give you some trick problems, we might maybe talk about, for example, let's try H2SO4. So this is sulfuric acid. It actually has 2 hydrogens. And let's say we go ahead and combine it with maybe something weird like aluminum hydroxide, AlOH3. So now we have a different ratio. So we're still going to produce H2O plus whatever our salt is, AlSO4, but now we have to balance things out. This is actually going to be Al2SO4 3, because SO4 is going to try and create our 2 minus, and Al is going to try and be a 3 plus. And then we're going to have to balance our whole equation. So you really want to be wary about when we do this. So in a problem like this, when you still have to balance it, you want to have our coefficients. So it's going to be 3, 2, 3, and 1. So you still have to be careful that your equations remain balanced throughout this whole process. So even though you know you're going to be producing your water and your salt, you still want to make sure you stay traditional to all standard chemical equation practices. Anyways, I hope this helps, and have a great day.